When you record?
So I'm recording now.
Take them out of a
I want to open your eyes to the beauty of something. Nitrogen, oxygen and fluorine are the smallest atoms in groups 15, 16 and 17. Smallest atoms compared to the period 3 atoms like phosphorus, sulfur and chlorine. They also the atoms with the highest electronegativities. Okay. So, the difference in the electronegativity when hydrogen joins to nitrogen is 0.9, hydrogen joins to oxygen is 1.4, and hydrogen joins to fluorine is 1.9. If I compare that to the bond that hydrogen forms with phosphorus, you say the difference in electronegativity is 0, so this molecule is nonpolar. It will have London forces between it, even though it will be like ammonia pyramidal. Okay? Sulfur joined to hydrogen, 0.4, so there's a degree of polarity. The molecule will be polar. And with HCl, there is polarity. Okay, so all of these molecules, except for the trihydride phosphide or phosphorus trihydride, will be polar, and they will have dipole-dipole forces between them. But the dipole-dipole forces between ammonia and water and hydrogen fluoride molecules are much stronger than expected. So they've got a different name. They're called hydrogen bonds. So, ammonia is a special case. Go away. Ammonia is a special case. No, not ammonia. Water is a special case. And hydrogen fluoride is a special case. Their dipole-dipole forces are so strong that they're called hydrogen bonds. Now I'm going to refer you to a table in your textbook. I just need to get the page. Right. So on page 68 in your textbook, you have boiling points. There's a graph there. Okay. You remember that I mentioned the heavier the molecule, the stronger the intermolecular forces. The heavier the molecule, the stronger the intermolecular forces. Okay, can you remember I mentioned that? It's very similar to gravitational forces. The bigger the mass of the object, the stronger the gravitational force. So intermolecular forces follows the same trend. Now there's trouble. So the boiling point, sorry for my abbreviation, of water is 100 degrees Celsius. What do I expect the boiling point of hydrogen sulfide to be? Higher. Now just listen. The boiling point of hydrogen sulfide.
Minus 60.2 degrees Celsius. According to PubChem, boiling point minus 60.2 degrees Celsius.
You see, it's not following the trend. The boiling point of hydrogen selenium.
Minus 41.25 degrees Celsius. According to some information I found on Wikipedia.
The boiling point of hydrogen tellurium.
So the heavier the molecule, the lower the boiling point is.
Sorry, wait. Okay, we need to talk about this now.
Yes. Guys, stop the session.
Okay, so you told me that you expect H2S to have a higher boiling point than water. Why? What is the mass of water, the molar mass of water?
Molar mass of water is 2 plus 16, which is
18 grams per mole.
Don't believe me, I'm not sure.
What is the molar mass of the hydrogen sulfide?
34.
34 grams per mole. What's the molar mass of they call it hydrogen selenide? 81. And hydrogen telluride? 130 grams per mole. Now, with an increase in molar mass, the boiling point should get higher. It's not happening. Water is an exception. So this, with the smallest mass, we expect the boiling point to be the lowest. We expect a lower boiling point. But because of the hydrogen bonds, the boiling point is higher than any of the others. Here, an increase in mass, are you aware enough? The increase in molar mass makes the boiling point increases. My lovies, listen to me. Minus 60 is a smaller number than minus 2. Minus 2 is a bigger number than minus 60. That is why the people doing the research on these molecules had to distinguish between water, ammonia, and hydrogen fluoride. Because they expected those molecules are the smallest molecules with the smallest masses. They expected their boiling points to be lower, the lowest, but it's not happening. The boiling points are the highest. And the only explanation they could come to was that these dipoles are so strong that they can classify the dipole-dipole forces as hydrogen bonds, to put them in another category.